So why this webinar? First of all, I want to keep the paper industry and the paper product relevant for the future. I mean, it's a beautiful, sustainable product, but as we know, it's also a competitive world. Printing grades have taken a serious blow by digital media. And who knows what will happen to our industry if bioplastics get cheap and threaten paper as a packaging material. And maybe you didn't realize, but these Japanese toilets, you know, with the one small shower inside, they're already quite popular in hospitals for the elderly and the physically handicapped. So even the future of tissue paper might not be as safe as we think right now. We therefore are obliged to continuously improve the paper making process, and we must look at all the possibilities to produce better and or cheaper paper. And machine clothing is just the shackle in the chain where I focus on. At the moment, I feel that quite a few paper makers leave the optimization of paper machine clothing a little bit too much to their suppliers. I have had my own experience where a paper maker once said that if the supplier makes sure that the machine is up and running, he would place the orders. No challenging goals, no real improvements, but just a reward to maintain the status quo. And that's not really what I would like to see, because that is not our ticket for the future. So my personal goal is to drive the innovation in paper machine clothing. The suppliers must develop innovative new fabrics and felts, but they also need the paper makers that are willing to do, they need paper makers that are willing to do trials, take a little risk, and support the suppliers with fact-based feedback on their product's performance. So what I hope to achieve is that one day paper makers will be comfortable enough to just as easily try a new felt or a new supplier as they do now trying to new tires on their car. Go to the part 2, the tips and tricks. And we'll start with the forming section. I've limited myself to 4 typical or less typical problems. For the forming section, of course, poor sheet profiles is definitely a common problem. What I hear sometimes as well is guiding, although guiding is not always considered a problem. It might be more important than some of you think. So that's why I want to discuss it as well. Dewatering, dry content, of course, always a discussion. And high wear, or at least fabric wear, reducing wear, whatever. We'll start with poor cross-machine sheet profiles. An uneven profile is a very common problem, and it can have many, many different causes. There is one indicator that seems to be neglected quite often, and that's the guiding line on the fabric. This painted line or stripe should be running straight. It should not look like a banana. It should not look like a boomerang, not like the letter S, but it should simply be straight and perpendicular to the fabric's edge. If it's not running straight, you probably have some kind of misalignment in your forming section, or at least some other reason for tension differences between the tender and the drive side. And both points here result in more corrections by the guiding system. And what does that all do with your sheet profile? Well, if you take a close look at a forming fabric, you'll see the entrance or the exit holes of the dewatering channels. I mean, in this picture, we look at the paper side of the fabric. Sorry, I was a little bit distracted by a question, which will be answered after the webinar or after the presentation, we now look at the paper side of a fabric, and we see the entrance holes of the dewatering channels. These channels, or at least the openings, have carefully designed dimensions to support the paper fibers and make sure there is still enough capacity to get rid of all the water. So under good circumstances, the dewatering channel should look like this. And I read the remark about, hey, this sounds like hike. Yes, it does. I borrowed this picture from them, but it's basically the same for all the foaming fabric designers. You have these dewatering channels, and the water needs to go through, and the fibers need to stay on top. Now, what happens if your guiding line is not straight? Here you can see if there's distortion in the fabric. In this fabric, especially the right-hand side is bent or distorted, and at the left bottom you still see three dewatering channels, which are very, very similar. I've looked up in the design where the watering channels should be the same, and in the top you see those three, which now suddenly have completely different shapes. The fiber support will be different there. The dewatering capacity will probably be less. The fines distribution there will be different. So, conclusion, tension differences in the fabric change the dewatering behavior of the fabric, at least locally. And that, of course, changes the cross-machine direction profiles of the sheet. So keep an eye on the guiding line and make sure it is running straight. Regularly check the tension of the fabric and solve any cause for misalignment. Ideally, the guiding roll must be in the center position most of the time. Which brings me to the next problem, the guiding roll. Just a little bit of a reminder on the working principle of the guiding roll. In this picture, you see a top view of the return loop of a forming fabric. The bottom side is tender side of the machine. The top is the drive side of the fabric, so the fabric runs from right to left in this picture. You can see that the guiding roll in the center of the picture moved to the left. And now remember that a fabric always moves towards where it first meets friction, which is over there. In the picture, you can see that the fabric is moving towards the drive side. And of course, the same applies when you move the guiding roll to the right. The same applies for your dewatering elements, especially the ones that create a lot of friction, like the suction boxes. If they are only just a little bit misaligned, if one edge only is a little bit closer to the head box than the other, the fabric will immediately go in that direction. This means your guiding roll will have to compensate for that by countersteering, and this has a number of negative consequences. Again, the shape of these dewatering channels that we saw before is now changed during the dewatering process. That will certainly not improve your sheet properties. Then the fabric is distorted twice per revolution, first at the suction box and then back again at the drive roll, the guiding roll. This creates unnecessary internal friction and wear, and that will reduce the fabric's life potential. In some incidents, the internal yarns can start fibrillating as well due to all the friction, and the yarn fibrils will easily catch all the fines that flush through the fabric, so your fabric will get plugged as well. And apart from that, continuous countersteering of the guiding roll creates wear on the paper side of the fabric, and this strongly reduces the life potential, as fabrics are designed to wear on the machine side only. But it also changes the contact area between the fabric and the sheet, and that could possibly affect your sheet surface properties as well. So if you have more questions on guiding, or you have your own guiding challenges, please take a look at the knowledge and white paper section on the Veldtest website. You can download some interesting articles over there. Poor dewatering, I mentioned it all before. The drainage capacity of the fabric is quite important. You need a certain dry content at the end of the forming section, so you need to get rid of a certain amount of water. The surface of the forming fabric is rather coarse compared to the dimensions of the fibers, so you really have to rely on a slowly growing fiber mat to retain more and more paper fibers, but you still need to keep enough drainage capacity. And I guess everybody here has seen this picture in one way or another before, so this is no news. But excuse me, I'll take a sip of water. Per machine type, per paper grade, per fiber quality, there are differences, but you always need a fiber mat to keep as many paper fibers in the sheet as possible. So a mild initial dewatering is therefore required. Again, no news. But as you've seen a few slides back, make sure that the guiding line is straight so that the dewatering channels are as designed across the whole machine. Otherwise, there will be certain areas where the initial dewatering is harder, and some dewatering channels will get blocked because fibers are pulled into the dewatering channels. This effect is sometimes also called a sheet sealing. Streaks in the fabric that are plugged because of this or sealed, they create local friction on the suction boxes. And obviously this causes more local wear of the fabric, but it also influences the stability of the fabric, as it will create small cross-machine direction forces, tension differences inside the fabric. And that again complicates the guiding of the fabric, which more or less means that we're back where we were before. And we'll now continue with fabric wear. Here you see fabric running on a thin water film over a stationary dewatering element, like a foil. If the fabric tension is low, especially when producing heavier grades, the fabric will sag between two elements, and this wears down both the fabric and the sharp edge of your dewatering foil. This sharp edge is responsible for most of the dewatering capacity of the foil, so it must be sharp. If it wears down, you lose capacity. And of course, your fabric is wearing down as well. If the fabric has large plugged areas, the water film could decrease, and especially on the vacuum supported elements. So therefore, locally plugged fabrics can also show locally higher wear. And of course, there will always be wear, but if the forces are really big and the wear is really fast, the yarn will sometimes start fibrillating on the bottom side as well, which is called bearding or beards, at least translated from, from Dutch, which more or less looks like this. I hope the picture is big enough for you to see that both the brown and the white yarns have fibrils, which can fetch again the fines and the small fibers that get through the fabric and start blocking your dewatering channels from the bottom side up. So despite the fabric getting thinner due to wear, at some spots the dewatering could be less, which is of course another possible cause for sheet profile problems. But wear is not coming only from stationary elements. Speed differences are also a very good reason for fabric wear. Yeah, there it is. When there are speed differences, usually the driven roll is moving faster than the fabric. If it concerns a not driven roll, the not driven roll is usually moving slower. But anyway, you have friction between the two. When the driven roll is going faster, usually the fabric tension is too low to transfer the forces from the motors from the roll to the fabric. There's a slip. So check and increase the fabric tension, which is one solution, or reduce the vacuum on the flat suction boxes, which is another, but that's a more expensive one. Not driven rolls moving too slowly is typically because they are heavy running, maybe due to damages to the bearings or its lubrication. And especially the rolls that touch the paper side of the fabric need to be watched closely, as again, wear on the paper side is not good at all. So if you suspect or you know that you have slip, regularly check the fabric tension, make sure it's high enough, and when in doubt, measure the speeds. Simply measure the speed of the roll by a tachometer and measure the fabric speed and see if there are any unsuspected differences. We now go to the press section, where we'll also discuss 4 problems. One is the sheet falling off the pickup felt all the time. We'll discuss some edge problems that occur in the 3rd or 4th press, where the sheet follows the felt instead of the granite roll. We'll talk about felt compaction for a bit and its consequence to dense felts. So we'll start with the pickup problem, which is more or less of an anecdote from quite a few years back, but it's still happening today, so it's still accurate. I mean, a minute ago we talked about the drive control of a drive, about speed differences between driven rolls and the forming fabric. That happens because the drive control system is using a calculated speed. The revs of the motor are measured, and that is multiplied with the circumference of the roll, and after that calculation you have the calculated surface speed of the roll. In this mill that I'm talking about now, somebody made a small typo when they entered a roll diameter. I don't know if it was in the workshop after a roll grinding or in the control room during the roll installation, but the fact of the matter was that the drive control system was calculating with the wrong circumference. After a maintenance shutdown, with, amongst others, a roll change and a pickup felt change, the machine suddenly had many breaks, up to 12 a day, and incredible pickup problems. Every so many minutes, the sheet just fell off the pickup felt. Long story short, during a period of close to 2 or 3 weeks, they replaced more than 2 pickup felts. They replaced the pickup roll, and they had a lot of lost production due to the poor runnability of the machine and additional shutdowns. Only after a long time, somebody decided to actually measure the speeds of the forming fabric and the press felt, the pickup felt, instead of relying on the drive control system, which said that every speed setting was all right. Only after the measurement, they discovered that there was an unknown speed difference of only 0.6%. The pickup was running 0.6% too slow compared to the forming fabric. After they fixed that, the number of breaks were normal again, and all the pickup problems had disappeared completely. As I was one of those felt suppliers in those days, I was quite happy that at least the papermaker was so kind to make his apologies, and he paid for the felts, which were in the end normal and good. The problem was somewhere else where nobody suspected it. After this anecdote, you might think we're getting serious now, but well, think again. Here you see the solution when your sheet is following the felt after the nip exit at the 3rd or the 4th press. When the sheet is not really sticking to the granite roll. The paper sheet always follows the smoothest surface. And normally a polished granite roll is much smoother than a hairy old press felt. But under some conditions, the felt hairs can be slightly pulled out of the fabric, out of the felt, and create a very smooth surface. So if your paper shows loose edges on the granite roll, just consider to buy a disposable razor and gently shave the edge of the felt near the sheet's run. I cannot guarantee it will work in your situation, but it's a rather harmless and cheap operation, and nothing's lost either. Now, a little bit about compaction and dense felts. I guess most people know what compaction is, but just to be sure, press felts are flexible fabrics that are pressed together in the nip, and at the nip exit, they expand again. At the moment the felt expands or recovers, it creates internal space to store water from the sheet and transport it to the Euler box. After a while, the felt will get less and less flexible, and the original height in capital H will be reduced to the lowercase h, and the felt is losing its flexibility. It's getting compacted. But that's a bit hard to quantify, compaction. So, but we can measure it, of course. That will not surprise you. Here you see a simplified piece of a press felt in a running paper machine. For simplicity reasons, I've drawn all the solid felt material, which is usually polyamide or nylon, at the bottom, and all the water that is normally distributed all over the felt is now focused on the top. With an appropriate measuring instrument, you can measure the caliper of the running felt in the machine. So again, that's the lowercase h on the left-hand side of the machine. But due to this picture, we realize that we not only measure the felt, we also measure the water. As you know, the felt weight and its density, because the density is the same as polyamide, you can calculate the solid felt component, S, in this drawing. So if you now divide the solid felt component with the total height or the total thickness of the felt, you have a very usable compaction metric. The higher the compaction is, or the higher the compaction percentage gets, the less storage there is for water. And this relates, of course, to dense felts. I mean, felt permeability has always been a very popular subject, especially when it comes to machines that mainly use box dewatering. The papermaker usually will notice it when one or more felts are getting too dense. Dewatering is not as good, machine speed is reduced. But what is the cause? Felts get dense due to contamination, but also due to compaction. But these different causes require also different corrective actions. So first thing to do is to measure the airflow through the felt at the box. If the felt is dense, you'll probably see a relatively low value for the airflow. Makes sense. So what's next? Simply, you need an extra measurement. If you also measure the felt caliper or compaction, it becomes a lot easier to distinguish compaction from contamination. Just take a look at this table and I'll go through it row by row. So if you measure relatively low airflow, but the felt is still rather thick, the felt is most probably contaminated and a felt washing is required. On the other hand, on the second line, if you measure a low airflow, but the felt is also thin at the same time, the felt is compacted, which means you better prepare a felt change at your next shutdown, because felt compaction cannot be undone. On the third line or third row, if your airflow is high and the felt is still thick, the felt is probably still in its break-in period, and that usually is costing you money, or at least it's costing you production. You can compact the felt a little bit and reduce the break-in period by running it with a little bit more water, by switching off one of the boxes or spray a little extra water on it before the nip. And that might help you to reduce the break-in period with a few hours or a few days, and it will also help you to reduce the re-wetting after the nip exit. And finally, if your airflow is high and your fabric is thin, your fabric is worn. So the felt needs to be replaced as well. Again, on this subject, there's an interesting white paper on the Veltis website on the knowledge and white paper pages.